Hello there, my name's Evan Bartlett. I'm with Jason Busby, and today we're going to teach you how to find the angle between two lines, a line and a plane, and two planes. Now, to start, we're going to do an angle between two lines. Here we have two vectors, vector u and vector v, and the angle theta in between. Now, the formula to find theta is going to be the arc cosine of the dot product of u and v over the magnitude of u times the magnitude of v. Alright, and the absolute value of that entire quantity. Now, we're given that v equals 3I minus 2j plus k, and u equals 3, 4, 6 plus 1, negative 2, 1s. Now we're only going to take into account this second part because that is the direction of the vector, whereas this is the starting point or the placement of the vector. So, to write them in easiest terms, we're going to have vector v, which is going to be 3, negative 2, 1, and vector u, which is going to be 1, negative 2, 1. Okay, so now we're just going to plug it into the formula, where theta equals the arc cosine of 3 plus 4 plus 1 over the square root of 14 times the square root of 6. And so the dot product is going to be the top one, 3 times 1. Then we're going to have, that's how we get our 3 here. Negative 2 times negative 2 is going to give us our 4. And 1 times 1 is going to give us our 1. And then we add the products together. Okay, so now that's going to equal the arc cosine of 8 over radical 14 radical 6, which is going to equal theta is going to equal 59.4 degrees. So we now found that the angle in between vector u and vector v is 59.4 degrees, which is going to be an acute angle.
Alright, what's up guys? It's Jason and I'm here to teach you how to find the angle between a line and a plane. Alright, so first off we're going to look at this picture over here. We have plane pi and line L, and basically we have this direction vector u that goes along line L, and we have the normal vector to the plane pi n, and basically the intersection right here is going to create this angle theta, this acute angle. So we're going to hypothetically say that this vector u is equal to 1 plus beta I plus 3 minus 2 beta j minus negative 3 plus beta k. And the plane, the Cartesian equation of the plane is going to equal 2x minus y plus z equals 2. Okay, so first off, we need to find the direction of vector u, which is going to equal 1, negative 2, 1. And we need to find the direction of the normal vector of this plane, which is going to equal 2, negative 1, 1, which is basically found by the coefficients of the Cartesian equation. Okay, so we're going to use the following formula. Theta equals arc sine of, it's going to look familiar from the last video, direction vector u dot product with the normal vector over the magnitude of vector u times the magnitude of the normal vector, absolute value of the whole quantity. Okay. You can also use, if you're not comfortable with using the arc sine equation, you can use the same formula we used in the last one and subtract it by 90 degrees of arc cosine instead of using arc sine, and you would have the same thing come down right here. Okay, so basically, let me erase these formulas for a second so I have some room. So theta, this angle right here, is going to equal the arc sine of, let me just write out this entire quantity, the dot product of vector u, and vector n. So basically, to do the dot product, we take the first two terms, multiply them together, so we get 2, plus negative 2 times negative 1, which is another 2, and then 1 times 1, so plus 1, over, now we're going to take the magnitude of vector u, which is the first term squared, plus the second term squared, plus the third term squared, all under the square root. So we're going to get the square root of 6, and then we're actually going to get the same thing for this normal vector magnitude, square root of 6. So theta is going to equal the arc sine of the absolute value of 5 over 6. So theta, you plug this into your calculator, is going to equal 56.4 degrees, and that's found in degrees, not radians. So what we're going to go ahead and do is utilize the equation theta equals arc cosine of the absolute value of normal vector m dot product with normal vector n over the magnitude of vector m times the magnitude of vector n. Absolute value of the whole quantity, boom. Okay, so the normal vector of this plane right here is going to be easy to find because we just use the coefficients because it's Cartesian. So go ahead and put that here. That's just going to be 2, negative 1, negative 1. Now, the normal equation, or the normal line rather, of plane 1 is going to be a little bit more difficult to find because we're given these two vectors here with beta and lambda, and those two vectors are 1, negative 2, and 0, 1, negative 2. We got to distribute the negative, and it's the value in front of beta, and there's no value for beta here, so it's a 0. And we're going to use that and do a cross product with the coefficients in front of lambda, so we have a negative 1, a 1, or a negative 1 rather, because we have to carry the negative again, and then a 0. Okay, so now we're going to actually make some space to do this cross product. So we have 1, negative 2, 0, negative 1, 0, and this is a really handy formula in your formula packet that'll help you with this. There's no use in memorizing it because you have the formula packet for the exam, so basically you're just manipulating the components of the vector. And that's going to come out to a grand total of 0, 0, negative 3. Okay, and so now we're going to use this vector along with the one that we previously found, 2, negative 1, because this right here becomes your normal vector m right here. So we're going to use that and plug them into the equation. Theta equals arc cosine of the absolute value of the dot product of both, which comes out to 0 plus 0 plus 3, or you can just simply write 3, over the magnitude of the first vector, this one right here, this one right here is going to be 9, and then the magnitude of the second vector, which is 6. So that's going to give you theta equals arc cosine of 3 over 3 square root of 6, which is going to come out to a total of 65.9 degrees. So again, this acute angle theta right here is going to come out 65.9 degrees when plane A is equal to this and plane B is equal to this.